Okay, we're now recording. Share the screen as usual. All right, so again, we're doing our one section a day, hopefully. So the calendar now looks like this, hopefully. So we're here, Tuesday, 3/16, doing 9.6. It's on something called the chain rule. Okay, and we have this section, then Thursday, the 18th, 9.7. Then next Tuesday, 3/23, 9.9. And then the 25th is just before our spring break. There will be exam number 3. Okay, so it's been a while since we've had an exam. This will be our longest chapter, as you can see. Right, so the first 2 exams came pretty quickly, but this one there's a lot more sections. And then looks like exam 4 has 1, 2, 3, 4, 5, 6 sections, and the last test has only 4 sections. So this one is definitely our longest chapter. Okay, so it's been a while, but reminder of the ground rules. So on the exam day, I'll let you ask questions at the beginning, and whenever the questions stop up until a limit of 5 o'clock at the latest. But if you have no questions right when we start, we can start earlier, and then I'll just give you more time for the test. And you must turn in the homework. So if I don't get at least 70% of the homework, then I don't grade your exam. Okay, as we said, the questions are just like the questions from the homework. And I usually give about 10 questions. So that means I guess I'll give 1 question per section and maybe a couple more, from other places. All right. And during the exam, you have to show your actual camera. So I don't require you to have your cameras on during regular days, as you know, but during the exam, your actual camera on with the true background. So no fake backgrounds back there. And during the test, keep yourself muted. If you have a question, put it in the chat. And if you finish early, you can just leave. Okay, so class will end as usual at our normal stopping time. So that would be what, 5:55 p.m. And then you can take a picture on your cell phone. Click, 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 right? Up until 6 o'clock. So you have to turn in the exam by 6, and then you have another half an hour, so 6:30 to submit the homework. But if you want to turn the homework early, that's fine. And early, my definition of early is any time after the day before. So once class ends on Tuesday, the 23rd, March 23rd, 3/23 here, once you finish class that day, then you can submit the homework. But I don't want it too early. Like I don't want it now. That gets me too confused. But once we finish the day before an exam, then you can submit the exam anytime after class the 23rd up until half an hour after class on the day of the exam, the 25th. So that would be what, 6:30 p.m. You can turn in the exam. As you can turn in the homework is what I meant to say. Okay. All right, so that's that. And so many people just joined. Okay, that's fine. All right, so that's where we're at. So today we're doing something called the chain rule, and your quiz on Thursday will be on this new chain rule. Okay, then we have 9.7, 9.9 next Tuesday. 9.9 is not really that long of a section, so it should be fairly fast for me to do that. And then hopefully the rest of Tuesday, I can answer questions. So that way, if you have questions on Tuesday, you can bring it up, and that'll just save us more time for Thursday's exam, Thursday the 25th, just before our spring break. Okay. All right, so we are up to 9.6. And assignment is 5 to 30, odd, 37, and 39. And as usual, I try to do as many evens as possible. All right, so any quick questions about the exam or anything like that, or before we go on to the new stuff? Okay, so let's go on to new stuff. So something called the chain rule. Okay. Chain rule. I'll show it to you in the book, although it's probably easier to think of it, in my opinion, when you actually do some problems with it. Okay, so 9.6, the chain rule and the power rule. That's where we normally do it. So that's on page 590. The formula is actually on page 591. Okay. You probably don't need this form here. So don't even look at that. This is what you want. Okay. You have a composition of functions, one function inside another function. Y equals f of u, but u is g of x. Okay. And in fact, let me write it like this for you. That's the same thing as what they have. It's a composition of a function. You have a function inside a function. So see where it says y equals f of u, u equals g of x. If we change u to g of x, it looks like what I wrote down. Then the derivative dy dx is f prime of u times g prime of x. That's correct. Okay, but I think it's better if you think of it this way, and I'll write that in for you. Y prime is f prime of g of x times g prime of x. That's the way it's normally written in many calculus textbooks. Okay, so even though what the text has is correct, I think it's probably easier to think of it this way. Okay, so you can put this on your cheat sheet if you wish. It's a composition of functions. You have a function inside a function. Y is f of g of x. So there's an outside function and there's an inside function. So the derivative of the whole thing is f prime of g of x. So you take the derivative of the outside function with respect to the inside and multiply it by the derivative of the inside function. So y prime is f prime of g of x times g prime of x. Okay. This might be very confusing right now. You say, I don't even know what you're talking about. Okay. It might be better if I just show you a whole bunch of problems. And then once you get the hang of it, then you don't really even need this, in my opinion. Okay. And not to mention, again, if we were meeting face to face, you wouldn't be allowed any of this. I'd make you guys memorize it. Okay. So I'd rather you know what's going on than just writing down a rule and you don't really know what the rule means. Okay. So let's go straight to some examples of how it works. Okay. So let me show you what we're up against in the text. Okay. And let me check the chat. Okay. Some people are still joining. All right. So in the assignment, and how far do we have to go up to? 9.6. 39 is the highest in my book. Okay, so page 594. So again, let me show you the problems. Okay, so differentiate. Okay, so if you casually look at some of the problems, like number 5, right? It's not just x at a 20th, it's some mess to the 20th, blah, blah, blah to the 20th. Okay, so I'll show you how to do that. And some more there. Okay, and let's see if I can get these here. I'm gonna have to adjust this a little bit. Yeah, 23 through 26. Aha. So A, slope of the tangent line, derivative. B, instantaneous rate of change, derivative. So same thing. A and B have the same answer. Okay, 27 through 29. Write the equation of the tangent line to the curve. So recurring theme. We see that theme over and over and over again. And skip the second part. As a check, graph both the function and the tangent line. So never mind about that. That requires a graphing calculator. So skip that. And let me look at our assignment again, see how far I had to go. So 5 through 30, okay, so that's that. And then we also had 37 and 39, a couple of word problems. So let me see if I can get you that. 37, okay, you can see that. It says velocity. How do you find velocity? Derivative. 39, marginal. What's marginal? Derivative, no big surprise. So you're still doing derivatives. So even though they give you a word problem in 37 and 39, it's not that big a deal. Okay. Frankly, you really shouldn't do this, but it's almost like if you don't look at any of the words, don't see any of the words, and you just see this equation, right? And say, guess what you're supposed to do? Well, this whole chapter has been derivatives, right? So I guess I better take the derivative, right? And velocity. Same thing for 39. It shouldn't be any mystery. I wonder what I should do. Take the derivative. and then plug in 100. Okay. So here we go. All right, so as usual, I'll do the evens and you do the odds that are equivalent. It's called the chain rule. So g of x is equal to 3 minus 2x to the 10th power. Okay, so there's an inside function and an outside function, right? The outside function is raising something to the 10th power. The inside function is 3 minus 2x. So here's the way this new chain rule works. Okay, so if I just had x at a 10th, the derivative is 10 x at a 9th, right? So it starts off the same way, right? So bring down the 10 for the derivative. 3 minus 2x to the 9th power, that's the same. Now the new part, the chain rule says it's times the derivative of the inside function. So I have to differentiate 3 minus 2x. What's the derivative of 3 minus 2x? Negative 2. Okay, so that's the way it works. You have to multiply by the derivative of the inside function. And then just do easy stuff like 10 times negative 2 is negative 20. So negative 20, 3 minus 2x to the 9th power, final answer. But don't multiply this out. That's crazy to raise that to the 9th power. Right, so this is how the chain rule works. You take the derivative of the outside function with respect to the inside. So 10, blah, 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 3 minus 2x to the 9th. Then the chain rule says times the derivative of the inside, negative 2. Okay, so that's an application of what I'm trying to show you right here, right? F of g of x that I wrote there. So the derivative is f prime of g of x, differentiate the outside function with respect to the inside, and then multiply by the derivative of the inside function, g prime of x. All right. Now, if you understood that first example, they're all pretty much like this, folks. We're just doing more and more varieties of that basic concept. All right. So again, I'll do evens. So number 6. Again, they're generally paired. So if I do 4, your number 3 should be similar. If I do number 6, your number 5 should be similar, and so on. Okay. All right. K of x. And yes, frankly, K of x is a little bit weird to me, but same thing as f of x. 5/7 2x cubed minus x plus 6 raised to the 14th power. Okay, so here's the way the chain rule works in general. Take 14 times that fraction. Then blah, blah, blah would be raised to the 13th, one less. And then times the derivative of the inside function. Okay, so 14 times 5 over 7, 14 divided by 7 is 2. 2 times 5 is 10. So my coefficient is 10. Then I have 2x cubed minus x plus 6 to the 13th power. And then the new stuff is times the derivative of the inside. Okay, so now only look at the inside. What's the derivative of the inside? So derivative of 2x cubed, 6x squared. Derivative of negative x is negative 1. Derivative of 6 is 0. So there we go. Okay, and as far as I'm concerned, you can leave it. Alternatively, I guess you could distribute the 10 with the 6x squared minus 1. I don't think there's any advantage in that. So just leave it. Now, by the way, yeah, if they didn't have the 1, the minus 1, and you had 10 times 6, you should do 10 times 6 is 60 x squared. But since there's a minus 1 on top of that, then it's okay, forget it. It's not really worth it. Okay. Right, so this is called the chain rule because you're chaining one derivative to the next. You're just multiplying one by the other and so forth. Okay, 8, P of Q. This might be price and quantity. Okay, so why don't they just use f of x? Well, P might be price and Q might be quantity. 4, 3q squared minus 1 to the 4th power minus 13q. Okay, this part should be very easy, right? What's the derivative of negative 13q? Negative 13, right? So that's easy. So get that out of the way. That's negative 13, right? So the harder part is this. So how do I differentiate 3q squared minus 1 to the 4th power? Again, I say differentiate. What does differentiate mean? Take a derivative. All right, so 4 times 4, 16. 3q squared minus 1 raised to the 3rd power times the derivative of the inside. So what's the derivative of 3q squared minus 1? 6q. And yeah, we have that minus 13. And yes, you should simplify easy things. Like if you have two numbers that are multiplied, you should just multiply, right? 16 times 6 comes out to be 96. So best final answer, 96q, 3q squared minus 1 cubed, 3rd power, minus a 13. And there we go. All right. Okay, number 10 looks like this. And that means I have a little bit more freedom on how to write the final answer. So look at number 12. And again, 11 is similar. Again, it's always paired. So like 13 and 14 are similar, 15 and 16 are similar, 5 and 6 are similar, and so on. Okay, so if you look at 12, the problem already starts off with a negative 5 exponent. Therefore, what does it mean for the final answer? I'm allowed to leave it as a negative exponent. But if you want to change it back to a positive exponent, I'll always let you, but in this case, you don't have to. All right, so P is Q cubed plus 1 to the negative 5. So outside function, raise something to the negative 5 power. And here's the inside function. So this is the function that I take the derivative of second. All right, so P prime, negative 5 comes down. Q to the 3rd power plus 1 raised to the negative 5 minus 1, negative 6. Right? And then the chain rule says times the derivative of the inside stuff. So what's the derivative of Q cubed plus 1? 3Q squared. You say, what about the plus 1? Well, the derivative of plus 1 is 0, so you don't have to write it. And yeah, take a look. Should I keep going with anything? Yes, the negative 5 times the 3, anything like that, you should always simplify. Do I have to change this to a positive exponent? No. Start off with a negative, so you can leave it with a negative. Although I don't mind if you change it. So negative 15q squared times q cubed plus 1 to the negative 6 is an acceptable answer. You may stop after that. Okay. Now again, if you want to put this into the denominator and put q cubed plus 1 to the 6th power, in the bottom, I'll let you. But in this case, not necessary. It started off with a negative exponent. You can leave the answer with a negative exponent. Okay, now piggybacking off of this example, question number 12. 1 over 4t cubed plus 1. Okay. You have an option of doing the quotient rule, but the quotient rule is probably our least favorite. It's the most messy, right? It's bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. Okay. My advice is if you have a constant on top, just like 1, make it look like this. Okay. So if your quotient has a constant, just a number, either on the top or on the bottom, I would avoid the quotient rule. I would write it like this. It becomes a lot easier. So 4t cubed plus 1 raised to the negative 1. And then I just do the same trick as over here, but there's one big exception in this case. The original problem did not start off with a negative exponent. So my final answer should not have a negative exponent. All right, so 1 over 4t cubed plus 1. If you did the quotient rule, it works, but I don't prefer it. It's usually easier when you have a constant on top, like 1 or 2 or 7, okay, to make it like this. Then I do the same thing as over here. All right, so g prime, negative 1. But if it's a negative 1, you can just put the negative sign, right? And not bother putting the 1. 4t cubed plus 1 raised to the negative 2. Negative 1 minus 1 is negative 2. Times, by this new chain rule, the derivative of the inside, 12t squared. Okay, so again, this is called the chain rule, C-H-A-I-N, chain rule. All right, and this time, unlike the previous problem, I was allowed to leave it with a negative exponent because it started off with a negative exponent, but not so for this one. The original problem did not have a negative exponent, so this thing must go into the denominator. Okay, so on top I'll have a negative 12t squared, and that's going to be in the denominator. So best final answer, negative 12t squared over 4t cubed plus 1 squared. Okay. Okay, side note, if you went ahead and did the quotient rule, you should get the same answer. That one part of it you can kind of tell. Part of the quotient rule, you have to square the denominator, right? You have to go 4t cubed plus 1 squared. And I notice that I already have that here. So that does seem reasonable, right? Okay. As a matter of fact, I went ahead and showed you that here. Okay, so suppose I did the quotient rule. So here's a little timeout that they're equal. So suppose I went ahead and did the quotient rule on 1 over 4t cubed plus 1. So it's the bottom times the derivative of the top. What's the derivative of 1? 0. We like multiplying by 0, that wipes that out. Minus the top, 1. Times the derivative of the bottom. Derivative of the bottom is 12t squared. All over the square of the denominator, 4t cubed plus 1 quantity squared. That's gone. Negative 12t squared over 4t cubed plus 1 squared. And as you can see, you get the same answer either way. But this way, you didn't have to do the quotient rule. Right, so it's a little bit better. All right, so we'll do that same theme for problem 14. Yes. Okay, y equals 1 over blah, blah, blah to the 3/2. I'm going to say bring that upstairs as 3x cubed plus 4x plus 1 raised to the negative 3/2 and differentiate that. Again, that prevents you from having to do the quotient rule. I really don't want to do the quotient rule on this, especially when you have a weird exponent like that. So let me do this. All right, so y prime, negative 3 over 2 comes in front. 3x cubed plus 4x plus 1 raised to the negative 5/2. It's negative 3 over 2 minus 1, negative 3 over 2 minus 2 over 2. That's a little minus 2 over 2 there, just for scratch paper. So it's negative 5 over 2 times the derivative of the inside. So what's the derivative of the inside? 9x squared plus 4. And once again, my original question did not have any negative exponents. So my final answer should not have any negative exponents, which means that goes into the denominator. So this joins the 2 in the denominator, and left upstairs is a negative 3 and then 9x squared plus 4. So here's how to write the final answer. Negative 3 is on top, 9x squared plus 4 is on top. On the bottom, you have a 2 and 3x cubed plus 4x plus 1 raised to the 5/2 power. Okay, and yes, optionally, you can distribute here if you want 3 times all that, but you don't have to. Okay. All right, so now we have some problems that involve square roots and such. Okay, so we know what to do with a square root. Square root means raise something to the 1/2 power, right? So we've seen that theme several times now. So they give us a few problems with that. 16, we just did. So look at 17, 18, 18, 20, right? They got these square roots there. All right, square root of x squared plus 3x, x squared plus 3x to the 1/2 power. All right, so dy dx. What's dy dx? Derivative. So dy dx, y prime, f prime of x, same thing. Okay, 1/2 comes down. X squared plus 3x to the 1/2 minus 1. 1/2 minus 2 over 2, negative 1/2, times the derivative of the inside, 2x plus 3. All right, so negative exponent means it goes in the denominator. Half means square root. So square root on the bottom joins the 2, 2x plus 3 is on top. Okay, so final answer, 2x plus 3 over 2 times radical x squared plus 3x. All right, so keep in mind, square root means raising something to the 1/2 power. X to the 1/2 means square root of x. So that's what I mean by that over there, okay? Okay, 18 looks like this. 5 radical 1 minus x cubed over 6. Here's another instance where you don't want to do the quotient rule. There's a constant on the bottom. Just treat it as 5 over 6 as a coefficient. That's way better, right? You can think of this as 5/6. Okay, so one more time. If you have a constant on the bottom, constant means all you see is a number. If either a constant is on the bottom or a constant on the top, like 1, 2, whatever, okay, I would say do not do the quotient rule. Simplify it first. So this one, I'm going to write as 5/6, 1 minus x cubed to the 1/2, right? That way I don't have to do the quotient rule. Whenever I can avoid the quotient rule, I will. So now I just, quote unquote, have to do the chain rule. I mean, it's still some work, but much less work than the quotient rule. Okay, so 1/2 times 5/6. 5 times 1 is 5. 6 times 2 is 12. 5/12. 1 minus x cubed to the negative 1/2. 1/2 minus 1 is negative 1/2. Same logic as, the previous one. And then by the chain rule times the derivative of the inside. So derivative of the inside, derivative of 1 is 0. Derivative of negative x cubed is negative 3x squared. All right, then just touch up. Negative in front of the whole thing. 3 cancels with a 12, leaving me with a 4 on the bottom. Okay, so I have a 5 on top, x squared on top. The 3 canceling the 12 leaves me with a 4 on the bottom, and then the square root on the bottom. Negative means it's on the bottom. The 1/2 means square root. So here's the best final answer. Negative 5x squared over 4 radical 1 minus x cubed. Okay, and then 20. 22, sorry. I got the numbers mixed up here, but look at 22. Guess it was 20 in the old edition. So 22, see how it has blah, blah, blah divided by 2? Again, don't do the quotient rule. Treat it as a coefficient of 1/2, i.e., think of it like this: 1/2 parentheses radical 2x minus 1 minus radical x. So that's partially the constant multiplier rule. If you have 1/2 times a function, the derivative is 1/2 times the derivative of the function. Okay, much better. All right, so leave the half alone. Both of these are raised to the 1/2 power, right? So 1/2, great big brackets, 2x minus 1 to the half minus x to the half. Okay, so what do I do with this half? Leave it alone. So leave this half alone. Now I differentiate everything inside the bracket. Okay, so this is going to be 1/2, 2x minus 1 to the negative 1/2 times the derivative of the inside, 2. That 2 is going to cancel that 2. Okay, and then minus derivative x to the 1/2, 1/2 x to the negative 1/2. Okay, and you just clean it up. This 1/2 stays. These 2 cancel out. So I have blah, blah, blah to the negative 1/2. So parentheses 1 over square root of 2x minus 1 minus 1 over 2 radical x. So there's my final answer for that one. All right. Okay, so now variations on the theme. Find the slope of the tangent line at the point 1, 0. Okay, so we've seen that game before. It's actually 26 here, I guess. Okay, but look at A and B. Slope of the tangent line, instantaneous rate of change, same thing. So I'm going to have the same answer for both of them. All right, so y equals 4x cubed minus 5x plus 1 cubed. I'm at the point 1, 0. Find the slope of the tangent line, instantaneous rate of change means derivative. After I find the derivative, I plug in 1. Okay, so let's differentiate. Again, differentiate means take a derivative. Okay, so 3 comes down. 4x cubed minus 5x plus 1 squared times the derivative of the inside. So derivative of 4x cubed is 12x squared. Derivative of negative 5x is negative 5. Derivative of 1 is 0, so don't worry about it. Now I plug in 1. So put a 1 here and here and here. So 3 times 1 cubed is 1. That's 1. 4 minus 5 plus 1, that's 0, isn't it? So who cares about all the other stuff? It's 0. That's 0. 0 squared is 0. 0 times 3 is 0. 0 times whatever that is 0. So the answer to A and B are automatically just 0. Okay, then we have the theme again of equation of the tangent line. Right. Find the equation of the tangent line at the given point. So that means make it look like y minus y1 equals m times x minus x1. Okay. So I have written down 28. I think it's actually 30 in this book, but it doesn't matter. You're not scheduled to do it anyway. You're just learning the material. Okay, find the equation of the tangent line at x equals 2. They did not give me the y coordinate. How do I get the y coordinate? Plug it in. Put 2 here and a 2 here. So let's see, 2 cubed is 8 minus 2. 8 minus 2 is 6. 1 over 6 cubed, 1 over 216. Right? So the point is 2 comma 1 over 216. X1, Y1. So already at this stage of the game, I know it's going to be Y minus Y1, Y minus 1 over 216 equals the slope M times X minus 2. I already know that. So right now I already have everything here. Y minus 1 over 216 equals blah, 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 X minus 2. I get that information just from here. Now I need to find a slope. Slope means derivative. So I differentiate. And again, the best way to think of this, there's a constant on top. So my advice, bring this upstairs and make it a -3 exponent like that, right? X cubed minus X raised to the -3. All right, so let's differentiate. -3, X cubed minus X to the -3 minus 1, -4, times the derivative of the inside. So what's the derivative of the inside? 3x squared minus 1. A little bit of touch up. Negative exponent, put that in the denominator. So upstairs, I have a -3 to 3x squared minus 1, and downstairs, x cubed minus x to the 4th power. All right, so that's the derivative anywhere. Now I want the derivative specifically at one point, 2 comma 1 over 216. I want the slope of the tangent line there. So I plug in 2. So what about the 1 over 216? That's the y coordinate. My derivative doesn't have any y's, so don't worry about it. I'm actually happy that's not the case. I don't feel like plugging in 1 over 216. I'm guessing most of you don't want to plug that in either. Okay, plugging in 2, well, better. That's maybe what I'll say. Okay, so y prime of 2, x is 2. So put a 2 right there, right there, right there. So -3 times, let's see, where am I? 3 times x squared. So 3 times 2 squared minus 1 divided by 2 cubed minus 2 to the 4th power. This gets kind of weird, actually. Let's see. 3 times 4, right? So 12 minus 1 is 11. So on top, I have -3 times 11. The bottom, this is 6. The calculation is the same as what we did over here, right? 2 cubed is 8. 8 minus 2 is 6. So it's 6 to the 4th power. All right. So I wrote it like this, -3 times 11 over 6 times 6 times 6 times 6. One of these 6's can cancel the 3, leaving me with an extra 2 on the bottom. So -3 times 11 over 6 times 6 times 6 times 6. Cancel, cancel. -11 over 2 times 216. -11 over 432. So that's my m, my slope. Pretty weird slope. But that's the way they gave it to me. I got to live with it. All right, so finally I can do the point slope form. Point was 2, 1 over 216. Slope is -11 over 432. So y minus y1, y minus 1 over 216 equals m, -11 over 432 times x minus 2. Stop. You can stop after that. That's the equation of the tangent line. Okay, I have more on the backside, but for focusing purposes, let me raise it up and show this to you again. So aim it. So hopefully you can see it better. I know I'm doing this fast, but again, you can always pause the video. So even if I just have a split second where it's focused, you can always go to that spot and stop, rewind, fast forward as much as you want. I'm just giving you a moment of time where it's focused in case you couldn't see it at first. That, okay, so I think I'm caught up. All right, so I have a few more on the back side. We'll go from there. Okay, let's see. My number 30, f of x equals 10 minus x squared minus 2x minus 8 squared. Okay, that looks like 32 there, actually. All right, find a derivative. Ignore B. C, slope of the tangent is 0. Set the derivative equal to 0. And then D, find points. Okay, make it into an x comma y. Okay, so it looks like 31 and 32 are similar. I'm going to do 32. It's written as 30 in my book because it was a change of addition, but it's the same problem. Okay. Side note, if the slope is 0, you have a horizontal line. That means you have a horizontal tangent line like this. We'll see that concept quite a bit in the next chapter. Okay, you might have a maximum point, a high point. You might have a minimum point. And we'll talk about that later, but slope is 0. All right, so find a derivative. Derivative of 10 is 0. And then negative 2 x squared minus 2x minus 8 to the first power times the derivative of the inside. So the derivative of the inside, 2x minus 2. All right, so that's the answer to A. Skip B. So C, set that expression equal to 0. So just a little bit of algebra. Negative 2 times x squared minus 2x minus 8. 2x minus 2 equals 0. Factor this. This factors into x minus 4, x plus 2. Then the zero factor property. If you have something times something times something times something equals 0, one of them's got to be 0. That means negative 2 equals 0, impossible. X minus 4 equals 0. X is 4. X plus 2 equals 0. X is negative 2. 2x minus 2 equals 0. A little bit of algebra, but x comes out to be 1. Okay, then the only thing for part D, they want you to translate that to points. A point is an x comma y. So you have these x coordinates, just plug back into the original to get the y coordinate. Okay, so for part D, I need f of 4, f of negative 2, and f of 1. So f of 4, put a 4 right there and right there. 4 squared minus 2 times 4 minus 8 squared. Okay, that's 16 minus 8 minus 8. 16 minus 8 minus 8 is 0. 0 squared is 0. So the y coordinate is 10. Right? So the point is 4, 10. Negative 2 also comes out to be 10 because if I plug in negative 2 back here, put a negative 2 there, put a negative 2 there, it looks like this. 10 minus bracket negative 2 squared minus 2 times negative 2 minus 8. This here also comes out to be 0 because it's 10 minus negative 2 squared is 4. Negative 2 times negative 2. Negative 2 times a negative 2 is positive 4 minus 8. So that's also 0. 0 squared is 0. 10 minus 0, 10. So negative 2 also gives me a y coordinate of 10. Not 1 though. Okay, so I'm plugging in 4, negative 2, and 1. Plug in 1 right here, and right here. 1 squared minus 2 times 1 minus 8. 10 minus 1 minus 2 minus 8 squared, so that's much different. 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. Negative 9 squared is 81. So 10 minus 81, negative 71. So 1 comma negative 71. And there we go. All right. And that's that, folks. All we have left are a couple of word problems and then just about finish. So I was going to do the marginal revenue problem for you, which was 39. 37, again, it's a word problem, but it's not that big a deal. Okay, just take the derivative and plug in 0.1. It says 1/10, right? 1/10 is 0.1. Okay, so maybe just jot down your notes if you want for 37. Take the derivative. The derivative of 27 is easy, right? 0. So take the derivative, plug in 0.1. You can write this down. Find S prime, plug in 0.1. All right, I'll do 39, even though I wrote it down as 37. Again, there was a change of addition, but it's the same question. So the revenue function is 1,500x plus 3,000, 2x plus 3 to -1 minus $1,000. X the number of units sold. Find the marginal revenue. What does marginal mean? Derivative. Then I plug in 100, interpret your result. Okay, so I'll do that problem. And that was the last problem I have done, folks. So it's only about 5:30-ish. I'll be done in a few minutes. So after a few minutes, if you have any questions, feel free to ask it. And if not, then we're done. Okay. And so then I'll be done. So again, a reminder, so next time, I'll go on to 9.7. The quiz will only be on this stuff, just 9.6 material on the chain rule. Okay, so I'm done in a few minutes. Quiz next time on 9.6. So 9.7 on Thursday, 9.9, and I'll leave time for question and answers because 9.9 will not take that long to do. Okay, it's a fairly straightforward section. So then I can take questions on Tuesday if you have any, and that'll make it easier for you for the test day on Thursday. You'll have more time if you can ask as many questions as you want on Tuesday. Okay. All right, so here's the problem. It asks for the marginal. Marginal means derivative. So R prime, derivative 1,500x, 1,500. The derivative of negative 1,000 is 0. So forget that. I mean, you don't have to write plus 0 because plus 0 means there's nothing there. So the only harder part is this one. -1 times 3,000 is -3,000. 2x plus 3 to the -2 power times the derivative of the inside, which is 2. All right, 3,000 times 2 is 6,000. Put that into the denominator, 2x plus 3 squared. Okay. By the way, you might say, I didn't have to put this in the denominator. Yeah, you really want to, since you have to plug in. When you start plugging in stuff, you don't want to have negative exponents. Okay, so you definitely want to put it here. That's the marginal. And then the problem asks, what's the marginal at 100? I plug in 100. So R prime of 100. Put 100 right there. 1,500 minus 6,000 over 2 times 100 plus 3 squared. 1,500 minus 6,000 over 203 squared. Okay, 1499.85. Okay, is my answer. And let me show you the interpretation there. So let me show you that in my calculator, double check. 1,500 minus 6,000 divided by 203 squared. Yeah. 1,500 minus 6,000 divided by 203 squared, 1499.8544. Okay, rounded to 1499.85 to the nearest penny. That's the marginal. So that means if we sell the next item, the 101st item, again, the production level is at 100. So if we sell the 101st item, we'll make approximately $1,499.85. I guess rounded off, you would say 1,500, right? So that's what it means. All right, I'm done, folks, and let me do my focusing job here, and then that's it. So raise this up a little bit, again, so you can see it. And a little bit more there. And the stuff I just did in the bottom. And then this thing on the far. Yeah. Okay, so that should pretty much do it. All right, I'm finished, folks. So I'll let you ask any questions. So if you have any questions, you can either unmute yourself or put it in the chat now. Otherwise, we're done for the night, folks. And we'll see you next time. Okay, so any questions, please? I'll wait just a moment. Okay, I don't hear anything and I don't see anything in the chat. So we're done, folks. All right, that'll do it for tonight. So everybody have a good evening and we'll see you next time. All right, thank you. Good night, everybody.
Thank you.
Thank you.
Okay, thank you. Bye. Yeah, if you join late, then yeah, please tell me or put it in the chat so I can make sure I get you for attendance. Yeah, so Kyle, I got you. Tin, Gia, I got you. You're fine. Okay. All right, thanks everybody. See ya. Bye.